Good morning, class, and welcome to this lesson on Geometric Optics 8, Converging and Diverging Lens Basics. Today we will be able to describe how the two types of thin lenses work. Okay, so this is going to be just an introduction into lenses and how they work, and then in the next few videos we'll discuss more specifically how to draw ray diagrams and calculate their different distances and lengths and whatnot. So basically we have two types of lenses, two types. We have converging. We have a converging lens, and we have a diverging lens. Okay, we have a converging and diverging lens, and so I'm going to show you these pictures on the next slide, and show you basically how these work. A converging lens does basically what it looks like it does in this picture. We have light rays coming. We have parallel light rays hitting the lens, and this lens focuses that light to a certain point. So as you can see here, the light is coming together. Or converging at a specific point. So converging, easy to remember, is that light is coming together. Light is coming together. Okay, so that's a converging lens. Okay, and why does this work? Why does this work that way? And that's because of refraction. Okay, refraction is the reason this works. So what I'm going to do here is I'm going to kind of zoom in on this and bring it down here. Okay, so I'm going to draw this lens nice and big here. Okay, this is my zoomed in version of the lens. And light's going to come in. I'll do a different color. Before I do that, I'm going to draw the normal. So this would be like the normal to this thin lens that is rounded, okay? And so light is going to come in like this. And so typically we're talking about going from air into glass, okay? And as we know, glass's index of refraction is going to be larger than air. And because it's larger than air, light is going to bend towards the normal. Light is going to bend towards the normal, okay? And then when it hits this surface, that is the normal right there. That is the line perpendicular to the surface. When it hits that surface, it's going from glass to air, not air to glass. And so when it's going from glass to air, it's going to bend away from the normal. So it's going to bend like this. So as you can see here, when we're going from air to glass, we're bending towards the normal, and we're going from glass to air, we're bending away from the normal. And so as you can see here, it hits the glass, goes through, and then bends away again. And so this is a zoomed in version of what's happening right here. You can see the light is hitting the lens and then bending towards the principal axis. Okay, same line as in mirrors. And so this is the reason why it is focusing or bending towards the principal axis, okay, because of refraction. However, for you as students, you don't typically have to draw this, okay? When we draw these, when we start drawing diagrams later, you're going to have a lens. You're going to have a lens, okay? And you would just draw a ray coming in to the middle, and then after the middle, it's going to bend away. And that's because we assume that lenses are thin. We assume that lenses are thin. And so because we assume that lenses are thin, they're so thin you don't have to draw two diagrams. It's just going to be a thin lens like this. It's going to hit the middle and it's going to bend towards the center. So that is how refraction works for a converging lens. And if we look at a diverging lens is exactly the opposite. So let's do the same thing we did before. Let's zoom in on this right here, down here. So we have this lens really nice and big like this. Okay. And let's draw the normal to the surface here. Like that. And let's draw a light ray coming in. And a light ray is going to come in this way, and it's going to bend towards the normal because it's going from air to glass again, and then it's going to hit this surface, and so we're going to draw the normal again for this surface right here. And as you can see, when it hits this surface, it's going to bend away from the normal, away from the normal. And so for a diverging lens, it's going to do exactly what it sounds like. It's going to diverge the light. It's going to make the light spread. The light is going to, the light will move apart. Okay, the light will move apart. And you can see in this picture, we have the principal axis again. For a diverging lens, the focal point is actually going to be the extension of the ray on the same side. So the focal point is actually going to be on the left side as opposed to the right side in these two pictures. So once again, we're going to assume that diverging lenses are thin. We're going to assume they're thin. And so when you draw a ray diagram, you're just going to draw it from the middle and it's going to go up like that. But the reason it diverges is because of refraction inside the lens. So that's the basics of how lenses work. We have diverging lenses and we have converging lenses. Principal axis is still going to be the same. Each lens has a focal point. They're going to be opposite each other. Diverging is going to be on the side light is coming in, and a converging lens is going to be on the side the light is going, so it's going to be going this way. And now you can see the basics of how refraction works for a lens.